So hello, my name is Meredydd, and I am here to talk about Anvil, which is a framework for building full-stack web applications entirely in Python. So that's Python in the web browser, Python running on the web server, obviously, even a Python user interface toolkit. And before I dive into giving you demos or showing you how it works behind the scenes, the natural first question is why? And to answer that, really, we need to talk about the web. Because the web is great as a developer platform. It allows us to build something that can be reached by anyone, anywhere around the world, but it is also an incredibly developer-hostile environment. Think about the web. If you build a web application using the standard technologies people use today, your data is going to go through a bunch of different forms. It's probably going to start out as rows in a database table accessed by SQL, but it's clearly not going to stay there. You're going to pretty much immediately turn it into objects in your server-side code, probably Python objects in present company, and those are accessed by methods and attributes. But you're immediately going to turn around and re-represent those as JSON delivered over HTTP requests with some kind of REST API, which is like it's different. It's accessed by this very large number of endpoints with this curiously limited set of verbs, only get, post, put, delete, and so on. But on the other end of those HTTP requests is, of course, another program written in JavaScript, which is going to reassemble them into objects with their own set of methods and attributes, and then turn around and turn those into HTML DOM, which has its own rather idiosyncratic API, and then use CSS to style those into the pixels on the screen. And that is a lot of different representations. And indeed, the day-to-day work of web development is in large part the work of transforming your data between these different representations. And that work is tedious and repetitive. And so, like all good programmers, we look to automate it. And the catch with a system like this is it really attracts the wrong kind of magic. Let me show you what I mean with an entirely unfair potshot at Sql Alchemy. So Sql Alchemy, if you're not familiar with it, is a library for automating one of those conversion steps. It allows us to access rows in an SQL database as Python objects. So instead of writing code like this, where you're selecting rows from a books table, you can instead write Python code like this. Query book filter book.prices less than 20. That's pretty nice. But of course, the process that takes that Python and turns it into SQL you can run against a database, it's black magic. We're talking meta classes, we're talking overriding innocent numerical operators to do something completely different to what they normally do. And if you use this in anger, you will find that out. If you try to treat book.price is less than 20 as if it were a numerical comparison, you're going to come unstuck. You're going to have to understand, actually, wait, what I'm actually doing is writing an expression using an overloaded operator with an object generated by a meta class that's going to generate some intermediate state that's going to be used to generate a program in a different programming language. And what you end up needing to know is you need to know Python, and you need to know SQL, and you need to know how exactly Sql Alchemy does the transformation. In exchange for that, of course, you get to build your applications faster. So you could probably get away with this if you do this once. But of course, we don't do this once, do we? We do this at every level of our stack. We have ORMs like Sql Alchemy helping us turn database rows into objects. We've got REST frameworks helping us represent those objects over HTTP. We've got JavaScript frameworks like Angular resources helping us turn those HTTP requests back into JavaScript objects. We've got templating engines like React helping us turn those objects into HTML DOM. We've got CSS frameworks like Bootstrap helping us turn those into pixels. And all of those are the wrong kind of magic. To deal with any of these frameworks, you need to understand the representation it's translating from and to, and how it works. So you need to understand everything in the blue boxes and everything in the yellow boxes now. I mean, we're Pythonistas. How does that stack up against PEP 20, the Zen of Python? Here's a famous one. Simple is better than complex. Well, that was not a simple system. So many moving parts. Let's look at another one. If the implementation is hard to explain, it's a bad idea. Well, you can either know how something like React works inside, or you can retain your sanity. There is no option 3. And possibly the most famous one of all, there should be one and preferably only one obvious way to do it. I mean, do I need to say anything more? The ecosystem is famously a mess. So the question we asked was, looking at this and looking at the way that the web was developer hostile, the amount you have to learn before you can even take your first steps, we naturally asked, how could we do it better? And if you're looking at this stack, you realize that just coming up with another web framework isn't necessarily going to help you very much, because you're just going to swap out something different in one of those orange boxes. But the work is all the layers and all the translation, so you haven't actually solved the underlying problem. So what we decided to try was forget all of these. Can we come up with one unified representation for every layer in this stack so you don't have to do the translations? And the representation we chose was Python. So we built a web framework in which everything from top to bottom is a Python object. A user interface toolkit in which the objects on your screen, like text boxes, buttons, and so on, are represented as Python objects. Run Python in the web browser. And so to drive your user interface, instead of generating source code in a language with 2 other languages embedded in it, which is what we do when we write HTML, instead of that, you just manipulate Python objects. Python on the server, obviously, but once you've got Python on the client and Python on the server, you don't need to mash all your application state into REST anymore. You can just make a function call. We even built a Python native database where the rows on tables are represented as Python objects. So now you can take something from your data store, a row from your database, and pass it all the way to the user interface without having to translate its representation. And that means that you can build your web applications really quite a lot more quickly and easily. But that's all talk. You want to see a demo. So let me find the right window and fire up the Anvil editor. So here I am at anvil.works. I have launched the editor, and I'm just going to show you building a simple sort of hello world type application. So what we're looking at here is a web page, and over here is a toolbox of things I can put onto that web page. So I want to put a title in. I'm going to drag a label, that's a text component, up here, and then you can see I can edit its properties. And so I can say the text is hello world. Okay, so far so simple. Let's be a little bit more interactive. Let's do something that prompts the user to enter their name and then greets them. So I want a card. I want a label to prompt the user to enter their name. Would help if I could type. Okay, we'll want a text box so they can answer that question. I'm going to call this name box. Everything in Anvil has a variable name, so we can access it from code. We'll want a button for them to click when they're done. Let's make this a little bit more prominent. And you can see what's going to happen. They're going to enter their name, click a button, and the message greeting them is going to appear. So let's add a final label, call it message label, for that message to appear on. And I can edit some more text properties. I can make it centered, and I can make it big, and so on. So I've just built a web user interface, and that was an awful lot faster than it would have been with HTML and CSS. But the really cool thing is this is all backed by Python. So if I double click this button, I am editing the Python code that runs when that button gets clicked. And all those things I've dragged and dropped onto my page are available as Python objects in my code. So let's zoom in. I want to set the text on this message label based on the text in the name box. So I can go self.messageLabel.text equals hello, and then self.namebox.text. And now if I run this, I have a working application. Let's put it online, publish it, publish the app. Let's choose a URL, hello Python austin.anvil.app. Okay, that app is now live. You can go to hello-python-austin.anvil.app right now, and you can see this application live. So what I've done is I have just built and deployed a web application entirely in Python, and I've done it, well, you saw how quickly. But of course, everything I've done so far is actually only client side. This Python code here is running in the web browser, which is great for building interactive user interfaces. But of course, any serious application is going to need some server-side code. So let's add some. To do this, we add a server module to our code. This is a Python module that runs on the server. And it's an ordinary Python function, ordinary Python module, where we can define an ordinary Python function. But what we can do is we can tag this function anvil.server.callable. And that means that this function, we can call this function, that's running on the server, but we can call it from the browser. So let's go back to our browser code. When the button gets clicked, as well as updating the user interface, I'm going to anvil.server.call the say hello function. It wants a name argument, so I'm going to pass in the text from the name box. And now when I run this, enter my name, you can see I've got something in the logs, and that print statement is running on the server. So now we're driving something on the server from this user interface we've built in pure Python. And now we're really in business, because of course there are limits to what you can do here. We are running in a web browser. There are limits to what we can cross-compile to JavaScript, but this here is a real Python environment. And so we can go to town. We want to connect to a database, import MySQL, connect, go. I want to do some data processing, import pandas, go. I want to do some machine learning, import TensorFlow. It's open season. In practice, though, the first thing everybody wants is a database, so Anvil has a built-in database.
Before you run to the database, you
yes.
can run it. Can you debug it?
Can we? Do you want to punt that to the questions at the end?
Okay, perfect. Yeah.
Right. So I'm just going to show you data storage first. So I'm going to, well, we could do an awful lot more. This is a database backed by Postgres, so you can stick gigabytes into this thing very happily. The application we built is a little bit less ambitious than that, so I am just going to record all the names of the people that got entered. So this is the visitors table. I'm going to add a text column for the name. I'm going to also add a date and time column for when it was entered. Right, so that's it. I just built my database. I can go back to my server code, and now when we run this function, instead of just printing the message, we can also take apptables.visitors, we can add a row to it, we can fill out the name column with the name that's been passed in, we can fill out the when column with datetime.now. Need to import that. And now when I run this code, enter my name. Let's go back to somebody else. All right. If we go to our database, we can see that data has now been added. So we just built and deployed a database-backed web application entirely in Python with very little effort. And again, this is live. You can also go here and enter your data, and it will really appear. This demo is live. Okay, so before I go behind the scenes and show you some of what's happening while we're doing this, I'd like to show you one more thing, which is how to display some data on the user interface. So let's go back to our user interface. Actually, the first thing we want to do is to get that data from the database. So when we start up, we want to pull the latest visitors. So we'll make a callable function, get visitors, and it's going to return at tables.visitors.search. Let's go to the user interface, go to the, well, let's see, let's zoom out just a little bit. There we go, so we get our toolbox back. Right, we're going to want somewhere to display it. So let's stick a data grid on here. I'm going to have a column for the name, a column for when it was entered. We don't need a third column at all. This is the name. We're going to pull out the name key from rows. The when is going to pull out the when key, and we can do things like adjusting widths and so on. So now inside this data grid is something called a repeating panel, and that's a component you can give a property called items, and you can set that to anything iterable in Python. And what it will do is it will go through that iterable, and it will instantiate this chunk of user interface for every element in that iterable. So if we go to our code, this is the code that runs when form opens, it's the constructor. We can set the items of that repeating panel to the return value of that getVisitors function. And when we do that, you can see it's populated our data grid. Now, one more thing. This data is kind of ugly. You can see what's happened, right? You've taken a datetime object and you have called stir on it. And the default string representation of a datetime is kind of ugly. So let's fix that. Let's go back to our user interface, edit this template, and instead of the default representation, I'm going to put a label here in the when column, and what I'm going to do is I'm going to use a data binding to set the text of that label to this Python expression. Now, self.item is the element from the iterable. In this case, it's a row from the visitors table, and so we can use that to pull out the when column. And of course, this is Python, so this is a datetime object, so we can use stirftime. So now, if I run this, you can see it's nicely formatted. So again, this is live at hello-python-austin.anvil.app. We have built and deployed a database-backed web application with a whole bunch of nice view features in a very short period of time. And so what I'm going to do now is take you behind the scenes and show you how that worked.
Awesome. Meredydd, would you mind if I jump in here with a question from the chat?
Sure. What's the question?
So you might be about to get to this, but Dimitri would like to ask a clarifying question. And this is, how exactly is the client speaking to the server that you just created?
Oh, yes, we are getting there. Don't you worry. So, yes, this will be covered. In fact, let me tell you a bit about what this chunk of the talk is going to be. So, first things first is to say that this is an open source framework. So anything that I don't cover, you can go check out on GitHub and dig through and find out yourself. But what we're going to talk about is how we compiled that Python to JavaScript. It's fairly important. How those function calls go between the client and the server, how we're passing these live database rows around, and then a little bit about the development environment as well, how that auto-completion worked. So let's start, because if we're running Python everywhere in a web application, including on the client side, then how that works is a pretty vital part. And the way we do this is we compile it to JavaScript, because a browser only understands JavaScript, and we want to write Python, so something's got to do the translation. Specifically, Sculpt, which is an open source Python to JavaScript compiler. So you feed it a string of Python source code, and it will produce a string of JavaScript source code that does the same thing. You feed it a Python function, it will produce, honestly, the ugliest JavaScript function you have ever seen, but it will have the same semantic effect as that Python function. Now, I'm going to take a moment and tell you the story of the first major modification I made to Sculpt. And this was in the realm of blocking versus non-blocking, because as you may know, JavaScript is an inherently non-blocking language. The rule is that in order for the browser to stay alive, interactive, usable, every function has to return immediately. It can't wait for I/O operations. But of course, many Python APIs, idiomatically, you want to write blocking code that can wait for something before it continues to the next line. So for an example, here is the kind of code that we would want to enable people to write. So we're going to go off and ask the database a question, and then on the next line, we're going to do some computation based on the result. This is the kind of nice API that Python programmers are used to. This is what it looks like to do that in JavaScript. That's 1, 2, 3 nested callbacks. Now, of course, in modern JavaScript, you would do that with promises or async await. Although I would point out I did in fact copy and paste this from the first page of the Postgres JavaScript API documentation. So the old ways are still alive. But even if you're using promises, you still need to understand that a series of callbacks is what's happening under the hood. It's one of those abstractions like SQL Alchemy or React that you're going to need to know the insides of it sooner or later, because it's just those mechanisms are just too close to the surface. But we have a Python to JavaScript compiler. Could we somehow automate the conversion of this into this? Well, yes, we can. Let's check it out and get exploring. So it turns out that the Sculpt compiler has a classic compiler architecture, unsurprisingly, closely based on CPython. So when you feed a string of source code into Sculpt, the first thing it's going to do is to tokenize it. These file names, by the way, they're the file names in the Sculpt source tree if you're following along. And this tokenizing it splits it up into substrings that are sort of sensible chunks for a language to work with, sort of the opening closing brackets, the identifiers, and so on. And then we will parse those tokens to produce an abstract syntax tree. And this is a tree of operations that represents that same program, but at a higher level. So what this says is, well, this line of code was actually an assignment, and it was an assignment to a variable named result. It was the expression it was assigning to it was a function call. We were calling a function named f with an argument which is the literal number 42. And then there is a compiler that crawls over that code, over that AST and emits JavaScript. So clearly, if we want to automate the process of turning blocking Python into non-blocking JavaScript, then this is where we're going to have to do our work. And so what we actually did was we preserved the rule that one Python function must become one JavaScript function, because it got very messy if you try to do anything else. And instead, we invented a new return type. So the JavaScript function could return and say, I'm returning because I'm JavaScript, I have to return, but I'm not done yet, I'm just blocking. And that type is a suspension. So for an AST like this, we generated code a little bit like this. So you do the call, and then you check whether the return value was a suspension. And if it is a suspension, then you save what's going on in the calling function. And that means you save all your local variables, you save all your temporaries, and you save where in the function you currently are executing. and you bundle all that into your own suspension and you return that. So here's how it works in a slightly more practical example. So here we are doing this blocking operation. So we have the Anvil runtime, which is handling, the reactions to button clicks and so on. That calls the button click one function, which calls the get method, which calls the database, and the database blocks. So it returns a suspension. The get method realizes it's been given a suspension. It saves its local variable, saves its temporaries, saves where it is in the function, returns a new suspension, wrapping that one. The button one click function realizes it's been given a suspension. It saves its locals, it saves its temporaries, it saves where it is in the function, and returns the suspension to the runtime, which sits on it. And that suspension contains within it a JavaScript promise. And a few milliseconds later, the database is going to come back to us, at which point that suspension will get resumed. Now, resuming suspension is actually, it's another way of calling the button one click function. But calling it, saying, I'm not really calling you, I just want you to pick up from where you left off, and here's the suspension where you left off. And so the button one click function will restore its local variables, restore its temporaries, jump to the right place, and then resume the inner suspension, which will again restore its state, jump to the right place, and restore the innermost suspension, which can, of course, return immediately because we now have the data back from the database. And we've sort of reinflated our call stack, and we're back where we were, and but now we have the data because we have blocked successfully. And that's how Sql turns blocking Python into non-blocking JavaScript so that programmers don't have to. If you want to learn more about this, you can head over to sculpt.org. I am one of the maintainers. We are always looking for new contributors. If you think this is cool, please do come in and join in. All right, what's up next? Function calls from the client to server. Again, that's a fairly important part of building a framework that lets you do everything in one representation. So Anvil enables you to write function calls like this. And you notice these aren't shaped like HTTP requests. They're Python function calls. They've got positional arguments, they've got keyword arguments, they've got return values. And the way this is actually implemented is a remote procedure call system over WebSockets with the arguments and return values encoded as JSON, which works fine for expressions like this one. But of course, you've just seen me slinging around objects that definitely are not dictionaries, numbers, none, and lists, and so on, such as those database rows or iterators you saw me throwing around. And it's reasonable to ask, so what do we do with the non-JSON data? And Anvil's answer to this is the Portableclass. So what you can do is you can take a class and you can decorate it with anvil.server.portableclass. And you write this class in a module that can be imported in both client and server code. And what this means is that when you pass an instance of this class to a server function, or you return it back from a server function, the serialization machinery goes, oh, I know how to serialize one of those. I'm going to take it, I'm going to send across a sort of encoded JSON message saying, hey, this is an instance of the potato class. And by the way, here is the contents of its dunder-dict. So it's instance variables. You can be more sophisticated than this. You can control its serialization. So you can say, oh, actually, I would like, when I send myself over the wire, I would like this to be my representation so I can be more compact. And you can do some very clever things. And so this sort of thing enables us to take rows from a database and send them through server-side code to client-side code, again, without having to change their representation. It's just a Python object you can pass around, which is a pretty neat property. But that's only half of it, because just because some client-side code some of the time has access to some of these objects. Doesn't mean that all client-side code has access to everything all of the time. Because remember, the client-side code, it's running in your web browser. It is completely untrusted until your client has proven to you who they are. And even then, you only trust them as far as you can throw them. So you don't just need to be able to pass this stuff around. You need the authorization for manipulating these objects. And for that, we use a capability model. Now, to use the more computer sciencey terms, capability is an unforgeable token that is used to prove authorization to access a particular resource. The plain English version is, if you've got it, you can use it. So the idea here we want to have is that by passing an object around, that is what grants the recipient access to that object. So the way we actually do this is we take the identity of some underlying resource. So for example, this is, row 42 of this table, and some permissions, read only. And then we take a digital signature over all of those things, using a key that is known only to the server. And then we can transmit that. And when the client or untrusted code wants to make a call, so it's making a call, it's manipulating one of these portable classes in the client-side code, it's calling a method on it. The implementation of that method is going to call back to the server to ask it to do something, update a database, search for data, whatever. It passes the capability. And the server checks the capability. And it says, well, this is a valid capability with a valid signature for row 42 of this table, read only. I guess I must have issued that, because you wouldn't have a valid signature unless I'd issued it. And so it allows the access to proceed. And you can build these capabilities in code. So here's an example of one that scopes to the database table 42, row 12 with read-only access. And there's a bunch of library methods for checking that they match a pattern you expect before performing an action.
Yes, Ashton.
So do we?
Somebody doesn't mute it. Okay, so with this model, this allows us to do cool things. So for example, we can return these objects from server code. So here's a server function that gets a person by name. So what we do here is we check whether there is a user logged in. This is using Anvil's built-in user authentication system. I don't even have time to talk about it today, but it's really cool. You can check it out in the docs. Check if the user's logged in, and if and only if so, do we return them that data. And of course, because there's a capability embedded in that object, only if we return a valid object can the client-side code call a function on it. In this case, it's calling the dunder get item function, which is what happens when you do a square bracket lookup. We can do cooler things than this. We can set the permissions that are going to be on that capability. So here it's the same function, but we get a client writable version of the people table, and we get the row from that. And now in the client-side code, we can get that object and we can update it. And this is safe because it's all guarded by that user check. We only had to do that permission check in one place, because if they have it, they can use it. We can be even fancier than that. We can return a view on a table. So imagine I have a table of records. Each record is linked to an owner, a row from the users table. And I want to return only the records which are owned by the currently logged in user. Well, we can do this. So here we are getting the currently logged in user, and then we check that that's not logged in. And if they're logged in, we get a client writable view of the records table, but a view of only rows where the owner column is the currently logged in user. And that is a portable class. We can send it back to the client. And now we have something that quacks like a database table. We can search it, we can add rows, we can delete rows, but only rows which are owned by the current user. And so we can safely delegate a lot of operations all the way out to client-side code. You can update your database in your button click handler. And so you no longer need to plumb every operation in your application all the way from the user interface down through all the layers down to the database. You can actually delegate that access upwards, which again makes it an awful lot faster. Okay, so we've talked about compiling Python to JavaScript. We've talked about calls between client and server. We've talked about those live objects and the capabilities that make them happen. I want to close out this section by talking about a little bit about the development environment you saw me using and one of my favorite features in it, which is autocompletion. So autocompletion is really vital if you want to make a nice to use web environment. It gives you discoverability. It lets you find out what's in an API without paging through pages and pages of manual. It gives you speed because you can just hit a few characters and hit the tab key. It gives you confidence that what you're doing is right because there are whole classes of bugs that you can notice and fix without ever hitting the run button because the autocompleter warned you that that wasn't what, that the type of this object, the spelling of that method wasn't what you expected. And for all these reasons and more, it feels good to use. If you are one of the holdouts still using Vim in text mode, you can get autocomplete too. There are plugins for systems like Jedi that allow you to add autocompletion to virtually anything. So if you are one of these holdouts, just try it for a week. You will be amazed. Unfortunately, an off-the-shelf system like Jedi wouldn't quite work for Anvil for a couple of reasons. One, of course, is that Anvil is full stack. So it needs to know about your database and your server-side code and even what components you've dragged and dropped into your user interface. Okay, fine, we probably could have hacked that into Jedi. But the more important point is that the editing environment is web-based. And Jedi expects a file system. And when you are editing in a code editor and you hit the tab key, there is just not enough time to go to the server, parse your code, autocomplete it, and bring it back. People type really very fast, and 200 milliseconds is about 195 milliseconds you do not have. So we built our own autocompleter in JavaScript, which would seem like a really challenging effort, except, of course, we have a Python to JavaScript compiler hanging around already. And you've already seen how we can use parts of Sculpt to parse Python code. So this is what the editor does. When you are editing Python code in Anvil and you hit the tab key, we replace your cursor with a random symbol, and then we feed the module you're editing into the Sculpt parser, and it will produce an abstract syntax tree. And then we can walk over that abstract syntax tree, building up a representation of what's going on. So we can walk into, oh, hey, we're inside a function called button1click. Okay, well, there's arguments called self and event args. So I guess those are variables that are accessible to us. Okay, there's an assignment to a variable named x. Okay, there's a variable named x available in this scope, and its type's a string. Okay, there's a function call here. It's named print. The argument, oh, here's our cursor. Well, I already have a fairly good idea of what's in scope at this point, so I can offer you, hey, you might want event arg self or x. Of course, you can autocomplete a lot more than just what variables are accessible. So here, the autocompleter is walking over. It's walking over what happens if you get app_tables.users. And then it's walking over what type you get if you get .search from that. And then you call that as a function. What type does it give you back? And then you iterate over that value. What type will it give you for each element in your iteration? And then if you do an item lookup square brackets, what options do you have? And this is what allows us to do things like auto-completing columns when you're talking about databases, which is quite cool. You can do even more than that, into and out of function calls. So here's a classic one. This is happening between client and server. So on the client side, in the web browser, we are calling a server function and we are passing arguments to it. And we really want the autocompleter to be smart about this. When we look at our server function, we want to know what the type of that argument is. So what we do is when we're parsing any code and we see a server call here, we make a note. We say, oh, here's a call to the say hello function, and here are the types of its arguments. And then sometime later, when we are editing the server module and we are parsing this say hello function, we can go, oh, wait, hold on. This is the say hello function. I know what arguments this gets called with. And so we pluck those out of memory, drop them into the local scope, and we autocomplete. You can actually, if you're doing it this way, you can autocomplete an awful lot about the types of variables you're using, which leads to a rather philosophical question of what exactly a type is. You could say, oh, well, that's easy. The type of an object, you get it with the type function in Python, it's the class. And sort of, but Python's a really quite dynamic language. You can add extra attributes dynamically to particular instances of objects. That's a perfectly legal thing to do. And even when two objects have the same class and the same attributes, you might not want to treat them as exactly the same. So, for example, these two dictionaries here, they're of the same class, they have the same attributes, but you want to treat them separately if you want to be able to do the item completions. So what Anvil does is we duck type the autocompleter. As far as we are concerned, these two variables have two different types. Obviously, they share a lot, but they are two different types and they autocomplete separately, and we keep track of them separately. So that concludes our whistle-stop tour of some of the behind-the-scenes stuff in Anvil. We've already fielded a couple of questions. I am happy to talk forever about more of what happens behind the scenes. But for now, I would like to wrap up by talking about the design philosophy behind everything you've seen so far today. And there are two big principles I would like to talk about. The first is that code is good. Not to be stating the obvious, but we are telling a computer what to do. We have been telling computers what to do for about the last 3/4 of a century, and in all that time, code has been the best way to tell a computer what to do. Text in a vaguely algebraic programming language. There's just nothing better we've found. Periodically, someone will come across the complexity involved in particularly web application development and say, oh, that's also nasty. Here's a way where you can build an application without writing any code at all, or by writing very little of it. And that's always a false promise. Because a system without code is either going to be very limited in what it lets you do, and you're going to hit a wall where there's something you need that the system won't provide. The computer can do it, but the system won't let you. Or you're going to be driving Cthulhu's own flowchart and desperately trying to approximate the logic that you know could be done with a 5-line for loop. And anybody who can drive a flowchart that complicated would probably have an easier time learning and writing the 5-line for loop. So get you to the code. The code is the right way to express this. Even in the user interface designer, you saw when I wanted to format those dates in that table, I didn't drag and drop some noodle from the database display onto the UI editor. No, I wrote a Python expression. And because I was writing a Python expression, when I wanted to format those dates, I could just use the Python standard library. Code is good. Get you to the code. The second and most important, I think, principle is to be accessible. And if I went out onto the street, onto the floor of a programming conference and asked what accessibility meant, I might get answers like, well, that means it's simple enough for a novice to use. And it's not wrong. It is important to be simple enough for novices. Frankly, it is embarrassing that we have built an ecosystem, a world where you need to know 5 different programming languages to put a button on a screen and make something useful happen when you click it. That's frankly embarrassing as a profession. So yes, absolutely, it should be simple enough for novices to use. Something should be. But on its own, that's not enough. If you just build something simple enough for novices, then what you've built is a playpen for the kiddies. And you've given them no room to grow, because today's novice is tomorrow's intermediate programmer, is next year's advanced person, and you need them to have space to grow their powers. But they're not the only people it's shortchanging, because if you just build playpens for novices, then you're doing a disservice to the professionals. I mean, these problems affect everybody. Just because I can write 5 different programming languages doesn't mean I want to, and it doesn't mean anybody wants to wait for me to do it. And so if you want to be truly accessible, you need to not just be simple enough for novices, you should be powerful enough for the seasoned professionals. And sure, I can almost see the eyes rolling, because the web especially has trained us to think that these are incompatible goals. It would be nice, but you just can't have something simple enough for the novices that's powerful enough for the seasoned professionals. Meredydd, it just can't happen. And to you, I would say, look at your text editor. What language are you writing? Everybody on this Zoom call is here because we use Python, which is the first language you show an 8-year-old who is sitting down with their first Raspberry Pi. But it's also the language that drives Instagram. It's the language that DeepMind used to beat the human mind at Go for the first time in recorded history. It is possible for programming technology to be simple enough for novices and powerful enough for seasoned professionals. We are sitting on living proof, and it is only the garbage fire of modern web development that ever lets us doubt it. Thank you very much.
I must applaud.
All right, you can hit me with those questions now.
No. Wait. There's some powerful language there at the end. I love it. But first, I must admit, first of all, I saw Anvil about 5 years ago or something like this, or 4 years ago. I think it was one Meetup as well, maybe even this one. And then what I saw is something slightly different than what you see. You're now arguing against web. At this point, building a simple database system was impossible, except from one competitor that hasn't been beaten for more than 20 years. The people who are old enough as me may remember something that exists in Microsoft Office. It's called Microsoft Access with Visual Basic at the back end. They did what you did with Anvil now about 20 years ago, but they had limitations. One of them is going to the web. You cannot go and do this on the web. Like at that point, I'm not sure what they're doing now.
I very openly, okay, there is a reason those things are called forms. Anvil owes an enormous debt to the RAD systems of the 1990s. Things
Really?
like Visual Basic, things like Delphi, because those were systems where anybody who could pick up a little bit of programming could and did build real applications. And then suddenly the web happened and we lost it. We had it. It's not like this is new technology we had to invent. We literally had examples sitting there and somehow we couldn't do it. I like, genuinely, a lot of the time before Anvil was invented was just my friend Ian and me just sort of sitting there going, come on, someone has to do this. Someone has to fix this problem. And nobody did. So eventually we said, well, might as well be us.
Well, and you did it. And this is marvelous, especially since this is Python. So you're preaching to the choir here. But now since it's an Anvil, let's hit you with the hammers. let's see. So I started before. One of the things, Microsoft Access was great in integration to the level that no one is able to do even today. Like you didn't even write SQL there. You would just draw SQL with all those like nice. You would just put in the tables and connect them, and it will write the SQL for you and stuff like that. So I understand that eventually Anvil will go to that if you take it in that direction. But for now, let's do the simpler things. Like, for example, Visual basically integrated with Access had a debugger inside part of it. Is it something that's you're going towards already have, or to some degree have?
I mean, you've already seen the integrated database layer.
Yeah, but you haven't shown me everything. Show me more. This is why I'm here. I'm asking you those questions.
I mean, what is it that you want to see? What capability are you asking about?
So you have like text. You have the script. Let's say I wrote some sort of like a button, and I have a bug in the button. And I want to debug it line by line and stop at line 5 and see if I get the correct values. Is it something you currently support, or something that you plan to support in the future?
This is on a recorded call, so I'm going to say very little about the future.
Okay. I'll stop answering. Okay, got it. Okay, I got your answer. But maybe someone else.
I have said nothing. I have said nothing. Disclosed
I got you from your answer.
So
Right.
first off, I'd like
Someone
to
else?
say, So first off, I'd like to say just thanks so much for staying up so late to come
Very
give us this talk. It is after midnight where he is right now. So thank you for doing this.
Yes, it is in fact 4 minutes past 2 in the morning.
It's quite late, so we'll let you go as soon as we can. We did have some questions in the chat that I wanted to make sure that I surfaced in front of you. So Dimitri would like to know if the database you're using is fixed to a single kind, or if you can bring in like your own Postgres instance from somewhere else.
Yeah, so the answer is that the Anvil built-in data tables are fixed to Postgres with a translation layer, because the point about those data tables is that they have the semantics of Python objects. That's not actually an SQL database by design, because if it's an SQL database, you have to write another programming language, or you have to use something like Sql Alchemy that tries to smooth the gap and has those gaps you fall down. So there is a great way to use your own Postgres database. It goes import psychopg2. This is just a Python program. You just do the Python thing. Okay, yeah. If you want, import SQL Alchemy. So yes, you can absolutely drive any database you like using the standard Python tools.
Awesome. Thank you so much for that. We have another question from Yvelin, and I don't understand half of the words in here, but I'll just ask what he has written. Is there a way to do something similar to what I can do with Beautify to code a material design PWA?
Right, yes, okay. I'm not familiar with the particular package you're talking about, but material design is, I mean, you saw that was an off-the-shelf theme. By the way, you saw there were a selection of several other themes. The themes in Anvil are defined in HTML and CSS, so you can't just define a new theme entirely in Python, but you absolutely can define your own. Nevertheless, material design is something that's that comes off the shelf. PWA is progressive web apps, so that usually refers to the ability to run your application offline or add it to your home screen on a phone. And yes, Anvil applications support that out of the box. So yes, I think is your answer.
Yeah, appreciate it. Is there a way? I apologize for coming in late. I had to take care of some stuff. Could you drop in the chat maybe a link to an example PWA with material design?
Sure. Yes, absolutely. There is. I'm currently standing up some distance from the chat, but I will stick it in before I go.
Thank you. It's very interesting stuff. Thank you.
If you're searching, you can just search the Anvil documentation for offline support, and there's an example you can clone. You can get the source code, just like an offline to-do app you can install on your phone.
Okay, I'll give it a shot. Thanks a lot.
Awesome. Thank you for that. We have another question here in the chat from CS, who says, I saw that you built your UI using pre-built components. Is it possible to define a custom UI component?
Oh, yes, it is. Okay, I can't resist the demo here.
We can't resist seeing it.
Okay, right. So what you can do is you can create a new form, and you can say, hey, this form should be usable as a custom component. Let's see, it has some properties, whatever. It can have default values and what have you, or it can emit events and so on. And at this point, let's see, you can then, going back to other code, you then have this thing in your component toolbox, and you can drag and drop it on. It now has all the usual properties and events as if it was something else built in. And you can absolutely package those up and package those up is applications. You can depend on those apps from other apps, and so build reusable libraries of these things. You can absolutely define them with in low-level HTML or CSS, or just use like a JavaScript interop. So a really common thing people do is they'll grab some component that's already defined in JavaScript that they want to use the JS interop bridge to create a Python class that drives it. So all the properties, they are Python at properties. Again, nothing magic about it. It's all the properties of a component are Python properties. You'll drive this JavaScript library using the JS Python bridge, and then you package that up as a custom component, put it in a dependency, and anybody who depends on your app can then drag it in from their toolbox and use it as if it were normal. There's a really great collection of these things called Anvil Extras, which is maintained chiefly by one of the guys in the Anvil community from the forum. And that's a really good example of a ton of these custom components that people have built themselves.
Awesome. Thanks so much for showing that. The surprise demo is always really fun.
Like the amount of effort
we have
that's
a
going
question
into
here.
not demoing in response to every one of these questions. Catch me at a conference sometime, like when it's in person. I'm really glad that I'm able to join you here by Zoom. I appreciate that in pre-pandemic times, you'd probably be actually, in a room together, maybe be able to get pizza. That would be nice. The downside of me being able to join you all the way in Texas from here in Cambridge is that there are none of those like between sessions at conferences, the deep demos where someone keeps asking questions and it just keeps rolling out. So it's nice to get a little bit of that.
We try to do it here as much as possible, but we can't ask you to stay too late. Dylan, unless you have other questions, I have something more.
Anything else in the chat, Dylan?
Yeah. Let's do just one last question from the chat because we don't want to keep you up until 4 o'clock in the morning.
Yeah, this is okay. I'm here to answer questions. I might as well go for it. Yeah, Jacob, you've already had your first one, so let's go with the chat first.
All right. So this is a question from Rod. It looks like it is a two-part question. And the first is, do you have to write the code in the browser, or can you use a regular editor? And then also, is it possible to put your application source code under source code control like Git?
The answer to both of those questions is yes, and it is yes at the same time. So here is our editor. Here is what we have been building this app this whole time. Here is the version control history. You can see that we can make commits, we can make branches. We can go and make changes to those branches. You can see that's made a new branched off commit. You can see the diff here is that I have added a component called label 3. I can, of course, merge this back into the master branch. And yes, of course, this whole thing is a Git repository I can clone onto my local machine. I can edit it with Vim or IntelliJ or Nano just to troll people and push it back up, and it just works. You notice that when I published, it's actually published the master branch. I can, in fact, control this control which version it appears on each URL, I can create different environments for my app that serve like different branches or different commits from my application. So the answer is yes, you can. There is deep integration with version control that allows for quite a lot of automation.
Terrific. Thank you so much.
Can I ask one more, or is there more, Dylan?
Go.
Let's do one last question from you, Jacob.
Okay, sure. So, assuming the time and organization that's outside the web, and I want myself being protected, but I like your tool.
Mm-hmm.
So, is there a way for me to actually, like, let's say I'm a government and I don't want, sharing anything with anyone else. I want it on my own servers and stuff like that. And I want to come for you and say, okay, bring me Anvil, but I want to actually keep my own data, my own code. I don't want to even do the, I'll pay you whatever. Is it something that you support?
Yes, there are two answers to that question. One is well, in fact, there are sort of roughly three answers to that question, depending on how carefully you are guarding your data. If you just have some on-premises databases, you don't really mind there being a cloud-based user interface for them, but like this database is staying behind my firewall, I'm definitely not letting code out there on the internet connect to my Postgres installation, no way. That's absolutely fine. There is something I haven't even had a chance to talk about today called the Uplink, which is a library you can install and then you can run anywhere. And so what you can do is you can pip install this Anvil Uplink library, run it as a little Python process inside your firewall. You get an authentication token, it connects to your app, and then you can write all those server-side code. So you can write an anvil.server.callable function that's running inside your firewall that allows you to make queries against that database, maybe only specific queries. And then you can call that from your app as normal. So option number one is to piecemeal expose bits of your data while still using the cloud hosting service. Option number two is it's an open source framework, run it offline. So I can write my application in the online editor, clone it out with Git, or of course I can write it with a text editor. There's nothing stopping me.
Wait. I can download the entire Anvil and do it on my own computer?
So the Anvil web framework, so the runtime part, not the editor, but the thing that hosts your applications, pip install Anvil app server. And that will, so what I could do right now, I'm not going to do it because, I'm restraining myself from the demos, but I could git clone that application we just built, pip install Anvil app server, launch the server in the source code directory I just cloned down, and it will start up a new server. It will actually even install its own database, its own directory. It'll install an HTTPS reverse proxy. We really try to make it easy, and it will self-host on my own machine. So you can build your app anywhere and then self-host it anywhere. So that's option number two. Option number three is, okay, I want everything behind my firewall, including the application development environment, the editor, everything. That is available as an enterprise installation, which it just comes as Docker containers. So what happens there is we send you a Docker Compose file, you go Docker Compose pull, Docker Compose up, and you have a full Anvil installation, including the editor, all the version control, the hosting, all of that stuff running on a server that can be firewalled off from the internet very happily.
Very nice. And open source.
So the runtime environment is open source. The editor itself is not.
Okay.
But again, you don't need it. You can absolutely edit an Anvil application with a text editor if you want. And the online editor is free. Everything you have seen me do today is available on our free plan. So you didn't have to pay for any of the stuff I've shown you.
Really? Hey, the most important part you didn't tell us.
Yes, I know. So I keep missing this stuff because I know, of course, this stuff's free, right?
Aha! You made me a happy man.
There we go. That's the aim. All right. Any more? Any more questions from the chat, Jake? Oh, sorry, Dylan?
Yeah. One more question here. This is a question from Sherry. What is the story behind the Anvil name?
Behind the name Anvil?
Yeah.
Oh, yeah. So hold on.
Yes.
sorry, something is eating this computer's CPU. Let me check what it is. It is, inevitably it's Zoom. Oh well, I'll just let it get on with it. The goal was it's a tool you use. It's a tool you find in a workshop, and it's a tool you use to build other things on top of. And that's why we chose it. Plus the domain was available. Not going to lie to you. It's an important consideration.
All right, that's absolutely true. Well, again, thank you so much. I'm speaking for myself and at least 4 other people in the chat. You've blown all of our minds here tonight. So everybody, let's thank the speaker for their time today.
All right, thanks so much.
Thank you very much for having me. It's been great.
Thank you. Awesome work. Impressive work.
My email address is over here on this on the slide, or I'm sure it's available on the event page, or you can Google me. My name is fairly easily Googleable, and get in touch. You can also check us out at anvil.works. Did I mention everything I'm doing today is free? Everything I did today is free. And there's also a forum where you can come and ask more questions. Thank you very much for having me, and I'm looking forward to the next speaker.
All right, thank you.